Welcome back, dear students. In our previous module, we have seen how to apply KVL in a single loop electrical network. Now, in this module, we are going to discuss about how do I apply KVL in a two or a more loop electrical network. Remember one thing, dear students, in exam, apply KVL in the number of loops where the number of unknowns are asked in the exam. For example, if two unknowns are asked, let's say it will be I1 and I2 current, so apply KVL in two loops. If three unknowns are asked, then apply KVL in three loops. Why? Because number of equations should be equal to number of unknown to find a unique solution. Now, let's try to understand how do I apply a KVL in this loop. I have two potentials or two EMF E1 and E2 and I have 5 resistances. Now, without wasting any time, let's go with the solution. Step 1. Name the circuit. Yes, dear students, name the circuit. So, I'll go with clockwise. So, I'll go with A, B, C, D, E and F. Yes, dear students? Perfect. Now, what is step 2? Yes, step 2 is mark the direction of current in the corresponding loop forming the circuit. Now, dear students, 2 EMF, so 2 currents. I1 will be for E1 and I2 will be for E2, going from positive terminal of the battery to negative terminal of the battery. So, let's assume I1 flowing from E1 and I2 flowing from E2. Now, dear students, at junction B, can't you see 2 currents are incoming? Hence, the outgoing current should be equal to I1 plus I2. Perfect. And again, touch branch E, the current will be splitted as I1 and I2 respectively. Now, dear students, let's try to apply KVL in on my first loop, that is A, B, E, F, A. So, let's hide the upper complex part. Why? To make the things complex, right? So, I've just hided the other loop. Now, when you apply A, B, E, F, A, the direction of tracing is taken in a clockwise direction. So, let's apply. I1 in the branch AB is equal to the direction of tracing. Hence, I can say it will be minus I1 R1. Then, similarly for branch B, again the direction of tracing and current is same. Again, it will be minus I1 plus I2 into R5. Same is the case in the branch EF. And we are going in the branch FA from negative to positive terminal of the battery, hence it will be plus E1 equal to 0. Now, dear students, when you re-simplify this equation, this is what I'll get. Now, dear students, first loop done. This is how I'll get KVL by applying this in equation loop 1. Now, dear students, let's try to apply KVL in the other half of the loop. So, when you apply KVL in the loop B, C, D, E, B, again I assume the direction of tracing to be clockwise because we have already seen it is irrespective of the direction of tracing, the equations comes out to be same. Now, what about branch BC? Opposite to the direction of current, hence it will be plus. What about branch CD? From positive to negative, so it will be minus. Then branch DE, again in the direction which is opposite to the current, so positive. And in the branch EB, again it is opposite, hence the product is positive. So that has to be equal to 0. Now again you re-simplify the equation, I'll get E2 is equal to this. Now, dear students, last loop is the bigger loop, that is A, B, C, D, E, F, A. So, in that loop, R5 is not useful for me, so I'll just eliminate R5. Now, again in the direction of tracing, yes, dear students, from A to B, I1 is in same direction of tracing, so minus. From B to C, it will be plus. From C to D, it will be minus. From D to E, again it will be plus, dear students, right? And what about for E to F? Yes, again it will be minus. Why? Because direction of current and direction of tracing is same. And what about F to A? Yes, from F to A, it is from negative to positive, so it will be plus E1 equal to 0. Now, when you re-simplify this equation, dear students, can I not say E1 minus E2 is equal to I1 R1 plus R3 minus I2 R2 plus R4. So this can be remembered as a shortcut that R1 and R3 has current flowing for I1. So it will be taken together, and R2 and R4 has current flowing I2. Perfect. So that's it for this module. Thank you.